Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So in this video lesson, I will talk about alcohols and carboxylic acids. Syllabus code is 5070 and 0620, which means that this course is for both CA, and IGCSE O-level chemistry. So here are the learning outcomes for this video lesson. Describe the manufacture of ethanol by fermentation of aqueous glucose at 25 to 35 degrees centigrade in the presence of yeast and in the absence of oxygen. Catalytic addition of steam to ethene at 300 degrees centigrade and 6000 kilopascal or 60 atm in the presence of an acid catalyst, including a comparison of the advantages and disadvantages of the two methods. So I will talk about the advantages and disadvantages of the two methods in terms of the time, labor, conditions, and other things. Describe the combustion of alcohols. State the uses of ethanol as a solvent, a fuel. So let's start the lesson with the meaning of fermentation. What is fermentation? It is the conversion of sugar, either glucose or sucrose, into ethanol and CO2 by the action of enzymes zymase found in yeast. So it is the conversion of sugar, glucose, or sucrose solution into ethanol and carbon dioxide. By the action of enzyme zymase found in yeast. Now this works best in the absence of air, which is anaerobic. Anaerobic means absence of oxygen. The other condition is the temperature, that is 25 to 35 degrees centigrade. And I've already mentioned that zymase is also involved. The zymase is the biological catalyst. Biological catalysts are known as enzymes. Now, why it works best in the absence of oxygen or anaerobic? The reason is that alcohol produced get oxidized to produce carboxylic acids if oxygen is there. Now here's a word equation for the fermentation. Glucose plus water gives ethanol plus carbon dioxide. So simple equation will be C6H12O6. I will write aqueous. Aqueous means it's dissolved in water. Ethanol is C2H5OH plus CO2. It's a gas. And this one is aqueous. So let's balance the equation. We have 2 moles of ethanol and 2 moles of carbon dioxide. So all the atoms are balanced here. Catalytic addition of steam to ethene. Now here's another method in which we can convert ethene into ethanol. Ethene is an alkene. So we are making alcohol from alkene. And how we are doing this? We are adding steam to alkene to get alcohol. Now, either temperature is 300 degrees centigrade and pressure is 6,000 kilopascal or 60 atm. The catalyst uses phosphoric acid. If you don't remember the name of the acid catalyst, you can simply write acid, or you can even write H positive. Because acid provides H positive ion, which will act as catalyst in this reaction. So it's a catalytic addition of steam to ethene. So the reaction will be C2H4. This is ethene plus H2O, which is steam. The product will be C2H5OH. This is ethanol. You can make other alcohols also by adding steam to other alkene. For example, if I'll take propene, the formula of propene is C3H6. This is propene. Now, if we add steam to this propene, you will get the alcohol C3H7OH, and the name will be propanol. Remember, the name of the alcohols end on all. Just like alkenes and alkane. Alkenes, their name ends on ene, ene, ene. Now let's talk about the comparison for the advantages and disadvantages of the two methods. Here we are having fermentation. We have fermentation and hydration of alkenes. So in fermentation, we are using glucose, which is coming from plants. So it's a renewable source. What are renewable sources? Renewable sources are sources which can be replaced once used up, can be replaced once used up. On the other hand, in the hydration of alkenes, we are using non-renewable resources because we are getting ethene from crude oil through the process of cracking. So we have non-renewable sources. Non-renewable sources are those resources which cannot be replaced. Actually, non-renewable resources are limited, but the renewable resources are unlimited. So in case of fermentation, you need lots of worker, labors are required, but in hydration of alkenes, you need only few labors. Fermentation is a slow reaction because it takes at least 1 week. On the other hand, hydration of alkenes is a fast reaction. It will take at a faster rate. So in case of fermentation, little energy is needed. So in case of hydration, lot of energy is required. You have seen the reaction conditions here, 300 degrees centigrade. Temperature needed is 300 degrees centigrade. And here you see temperature, 25 degrees centigrade to 35 degrees centigrade. Now, in case of fermentation, you need to purify the products. The reason is that you're not getting only one product, you're getting alcohol, ethanol plus carbon dioxide. So it means there are two products. And one more thing that is ethanol is soluble in water. So there's a water also. So carbon dioxide produces a gas, it will be removed, but the ethanol need to be distilled off from the mixture of the miscible liquid, which is ethanol plus water here. In case of hydration of alkenes, we have pure product because only one product is produced. Only one product, that is alcohol. Now, reaction condition, I don't want to repeat these reaction conditions. I have already discussed the reaction conditions previously. Oh, combustion reactions of alcohols. Now, let's talk about the combustion reactions of alcohols. So in case of complete combustion, you will get carbon dioxide and steam or water. For example, if you are reacting combusting ethanol, you have C3, C2H5OH plus O2 gives CO2 plus H2O. Now let's balance the equation. Carbon, I have to place 2 before carbon dioxide in order to balance the carbon atom. What about hydrogen? It's 6 atoms on the reactant side. So I have to place 3 before H2O. So you have 3 moles of water. What about oxygen? 2 multiplied by 2 is 4. 4 plus 3 is 7. So you need 7 atoms of oxygen on the reactant side. 1 is already in the alcohol. We are left with 6. So I will write 3 before O2. Let's talk about incomplete combustion of alcohols. Here you will not get carbon dioxide. Instead, you will get carbon monoxide besides steam or water. Same alcohol, I'm taking C2H5OH plus O2 gives CO plus H2O. Carbon, 2CO. What about water? 3 moles of water. Oxygen, 3 plus 2 is 5. So I'll simply place 2 before O2. Now the oxygen atom is balanced on the reactant side. Now uses of ethanol. It's used as solvent in industries. It is used as a solvent in the industries and as a fuel. So if in the exam, they will ask you write down the uses of other alcohols, what you will do is simply write they're used as industrial solvents. So they all are usually used as industrial solvents. So you can straight away write industrial solvents. Now, new learning outcomes, which is related to carboxylic acid. Describe the reactions of carboxylic acids with metals, bases, carbonates, including names and formula of the salts produced. Describe the formation of ethanoic acid by the oxidation of ethanol with acidified aqueous potassium manganate. 7, just came in 4. By bacterial oxidation during vinegar production. Describe the reaction of a carboxylic acid with an alcohol using an acid catalyst to form an ester. Reactions of carboxylic acids. Now with metals, whenever you get carboxylic acids with metals, you will get metal alkanoate plus hydrogen gas. For example, if you are reacting methanoic acid, this is a formula of methanoic acid, HCOOH, and the metal I'm taking magnesium. So you'll get magnesium methanoate, magnesium methanoate plus hydrogen gas. Now magnesium methanoate, you have to predict the formula of magnesium methanoate. Magnesium, this belongs to group 2, so the valency for magnesium will be +2. What about methanoate ion? For the methanoate ion, remember one thing, simply remove hydrogen. For any carboxylic acid you are taking, simply remove the hydrogen because in acid, it will dissociate to produce H positive ion in the solution. So you will be left with HCOO. And the charge over the valency on HCOO, it's -1. Ignore the charges, you will get 1, 2. These subscripts will be exchanged and you'll be left with HCOO whole twice Mg. So the final formula for the salt will be HCOO whole twice mg. You know the formula for hydrogen gas, not difficult, plus H2. This will be the other product. Now, I want you to work out the reaction of ethanoic acid with zinc. Remember, the valency of zinc is +2. Product will be, I'm just writing the name of the product. We'll get zinc ethanoate plus hydrogen gas. Now, next reaction is the reaction of carboxylic acid with bases, which is carboxylic acid here. So the product, again, the product will be metal alkanoate. This is a salt and plus water. So I was talking about the reaction of carboxylic acid with the bases. In this case, you will get metal alkanoate and water. Now, this time I'm taking the carboxylic acid, ethanoic acid. The formula will be H3COOH. And the base, you can take any base. Like NaOH. So in case of carboxylic acid, I'm taking ethanoic acid. Formula for ethanoic acid will be CH3COOH. Now for base, you can take any base like metal hydroxides, alkali, sodium hydroxide. Product will be metal alkanoate plus water. You know the formula for water. What about the formula for metal alkanoate? You will get sodium ethanoic ethanoate because we have ethanoic acid. You get sodium ethanoate. Sodium belongs to group 1, so the valency of sodium ion will be +1. And as I've already told you, just remove the H from carboxylic acid, you will get CH3COO. So the charge will be -1. Ignore the charges. Final formula will be CH3COONA. In the same way, you can predict the formula for other salts produced from reaction of carboxylic acid with other bases like metal oxides. Try with magnesium oxide, zinc oxide. You can take methanoic acid. You can take propanoic acid. You have C3H5COOH. Try these by yourselves. Now, what you will get in case of metal carbonate, you know that in case of metal carbonate, whenever you get acid with metal carbonate, you will get 3 products. You get salt, plus carbon dioxide plus water. Same way you're going to predict the formula for metal alkane. I'm writing the formula for carboxylic acid and carbonate here, and I want you to work out the formula for the metal alkane in this case. Carboxylic acid, we are taking methanoic acid, and for carbonate, I'm taking calcium carbonate. Alcohols on oxidation gives carboxylic acid. Oxidation is the gain of oxygen and loss of hydrogen. This is something which you have to recall. You can take any alcohol. For example, I'm taking the alcohol methanol here, CH3OH. So the carboxylic acid here produced will be methanoic acid. This is methanol. You will get methanoic acid. The formula for methanoic acid will be HCOOH. Methanoic acid. Now, this is an example of oxidation reaction as it's written that there's a gain of oxygen and loss of hydrogen. Let's count the number of oxygen and hydrogen atoms on both sides. So we have oxygen and hydrogen, both sides of the reaction. On the reactant side, we have one oxygen. On the product side, we have two oxygen. What about hydrogen? On the reactant side, it's 4, and on the product side, it's 2 now. So you can easily see that there's a gain of oxygen and loss of hydrogen taking place in this. Let's do this with another alcohol. Now the conditions of this oxidation, remember it takes place either in the presence of acidified aqueous potassium magnate, which is KMnO4, or it can also be done by the bacterial oxidation. The formula for potassium magnate is KMnO4. KMnO4 is the oxidizing agent. Do the oxidation of ethanol. This is ethanol. Just writing the name of the product, you will get ethanoic acid. And count the number of oxygen and hydrogen atoms on both sides of the reaction. The application for this reaction is that you can make vinegar from ethanol. Vinegar. Vinegar contains ethanoic acid. So there are two types of vinegar. We have synthetic and the other one is natural. The natural vinegar contains 5% of ethanoic acid. But in synthetic, it's 6%. That's the difference between synthetic and natural vinegar. What is esterification? Now, whenever a carboxylic acid is warmed with alcohol in the presence of few drops of acid like sulfuric acid, fruity smell compounds are produced. They are known as esters, and this reaction is known as esterification. When carboxylic acid is warmed with alcohols in the presence of few drops of acids like H2SO4 or HCl. Again, here H positive ion is acting as a catalyst. A fruity smell compound is produced. Now, this produced phenol compound is ester. You can take any alcohol. For example, I am taking methanol. To react methanol plus carboxylic acid, like methanoic acid. You will get ester, methyl methanoate, methyl methanoate plus water. How you're going to draw the displayed formula for this ester? Just look at the technique. So formula for methanol is the displayed formula for methanol. Carboxylic acid. This is a displayed formula for methanoic acid. Remove H positive ion from acid and OH from alcohol. So you're getting alkyl from alcohol. In this case, you'll get methyl alkyl from the alcohol and the alkanoate coming from the carboxylic acid. So you'll get methyl methanoate. Formula will be like this. HC O C double bond O H. This is methyl methanoate. Thanks for watching. Press like, give comments and share my videos. For more videos, subscribe to my channel, press the bell icon.